Automation scripts are great at ensuring that your product's functionalities are working, the keyword being functionality. However, scripts simply execute commands and verify that the expected results happen. They don't observe the screen or monitor browser metrics to identify qualitative aspects of your application, such as is the UI visually pleasing? Are there labels that overflow their panels? Are there untranslated strings or accessibility issues? Or even whether the page takes ages to load. And those types of issues are referred to as non-functional requirements of an application. Your product could be functionally working, yet be completely unusable if it is filled with those kind of bugs. And this can have real revenue impact. Research after research finds that bad UX churns users away and affects retention, since those bugs give an unfinished feel, pushing users toward your competitors. But teams often skip this part since it used to require manual testing. This is what ExploreChimp solves. In a nutshell, ExploreChimp walks through your app, guided by tests, and along the way analyzes UI, DOM, network, browser matrix, and console logs to catch various bugs such as performance, security, accessibility, internationalization, visual, layout, etc. It attributes each of those bugs to the screen they were found at, which you can view in the Atlas page. The Atlas page shows your app structure as a tree of screens and states within. A screen is basically something like a login page, dashboard, settings page, etc. Each screen can be in different states, and the UX can differ based on the state. For instance, a settings page may differ based on whether the logged in user is an admin or not. A cart page may differ based on whether there are items added to or not. Those represent states of that screen, and bugs are attributed to the specific state of the screen at which they were found. We will get to how the screen state naming is done by TestChimp in a bit. ExploreChimp doesn't work in isolation. It utilizes your end-to-end tests as a guide to walk through your app. This gives it a few advantages over other solutions where the pitch is give us the URL and our agent will find bugs. Usually, modern apps are quite dynamic, displaying different behaviors for different user situations. Take a simple example. Say your site provides a free trial, and after expiration, the user is shown a different UX. Agentic solutions that take a URL and walk through are not going to be able to discover the post-free trial experience, since it will have to wait a couple of weeks before that happens. But ExploreChimp uses your tests as guides, so it can navigate to any situation, area, or user journey in your app and analyze the UX at different states. Secondly, since all our tests are traced to scenarios and stories, the same traceability extends to the bugs that ExploreChimp finds. You can view those by going to the Insights tab in the Plans page. Basically, this allows you to find what UX bugs are affecting the checkout user journey or settings page related stories. Third is that it gives you control over where analytics happen and how the screens are named. Let's take a look at how ExploreChimp works using tests. When you run the test workflow, agent authors tests in a specific way. It uses a special fixture provided by TestChimp Playwright plugin called Mark Screen State. This is used by your agent to mark screen state transitions they observe during test authoring. Now, one challenge is, what if during one test the agent names your login screen as login, but in a different test it calls it sign in? To avoid such drifts, it coordinates with the TestChimp platform via our CLI to ensure the vocabulary stays consistent across tests. You can edit them freely to fit the vocabulary that you want to use. ExploreChimp uses those steps as anchor points to run analytics and attribute the bugs found to the named screen state, deduplicating against previously found bugs at the same place. When ExploreChimp visits a specific screen state, it checks if there is a baseline image on record. If this is the first time it is seen the screen, it records that as the baseline image. You can view the set of baseline images in the Visual Regression tab in Atlas. Then the next time it walks through the same screen state, it will compare against the baseline image and report any regression bugs. Since it uses LLMs to do the comparison, it avoids reporting noisy changes, which is usual with pixel-based approaches. And this means you don't have to buy another tool to do visual regression. For all those bugs reported, you can mark them as ignored, if not useful, or is intended behavior. And this information will be used by ExploreChimp as knowledge when reporting new bugs. When you run the test and evolve workflows, ExploreChimp is run on the new and updated tests that were authored during the workflow, so that any new screens that were added are scanned for UX bugs, and any regressions in existing screens due to the PR are found. You can directly invoke ExploreChimp by executing /testchimp explore workflow if needed as well. So to recap, automation scripts are great for ensuring the functionality of your app is intact, but they cannot seed the screen and identify various non-functional bugs that are still crucial for the quality of your app. ExploreChimp walks through your app, guided by your tests, to identify such bugs and report them, aligned with the app structure, so that you can keep track of and address those non-functional issues, making sure that the shipped product is polished and production ready.